All right, well, today's lesson is about really circle vocabulary. We're going to be talking about things like radius, chord, diameter, secant, but especially tangent and a couple special properties of tangents. So, looking at problem number 1, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. So let's see, segment DF. Looking at segment DF that's going like this, well, that is a chord. Look, these pictures tell the story of your basic vocabulary. You got your radius from the center to the edge, your random chord that begins and ends on the circle, a diameter, which is really a special kind of chord. It's a chord that goes through the center, and then a secant, which is a line that cuts through the circle. I really want to emphasize that. A lot of kids will get confused between a chord and a secant because they're pretty similar in the way that they can sort of randomly cut across a circle. The difference between a chord and a secant is a chord is a segment. It begins and ends on the circle. A secant is a line. It goes straight through the circle and it keeps on going forever. And then last but not least, tangent. This is a tangent. It's a line or ray or segment that just intersects the circle at one point. So it sort of grazes the circle like that. And of course you can have a common internal tangent that sort of goes between the two circles, or you could have a common external tangent that goes along the outside of the circles. Anyway, so looking back at problem number 1, we can see that DF, see how the symbol over the DF is a segment. That's how I know that it is a chord. B, so let's see, AB. AB is a tangent. Segment CE, where is that thing? Segment CE, that's this guy right here. That is clearly a radius. Segment DE, clean this up a little bit. Segment DE is right here. That is a diameter. Line AG. Okay, line AG is a secant. Remember what we just talked about. A secant, looking back at our vocabulary, a secant is a line that passes through the interior of a circle, and that's what AG is doing. Line AG, a secant. And finally, ray EB. Ray EB is up here, like this, and that is another tangent. Okay, all right. Number 2, draw a circle P, draw a tangent ray on the circle, and label it ray CD. So here's circle P. When it says circle P, that just means P is the center of the circle. Now we're supposed to draw a tangent ray and label it CD. So a tangent ray might be something like this. Okay, so that's a ray, and it's just intersecting at one point, so that makes it a tangent ray. If it's going to be ray CD, that means the end point of the ray has to be C, and then it has to pass through point D. Okay, so there it is. Let's see. So that was number 2. So I'll just put number 2 over here. Number 3, we're supposed to draw a circle P again. In fact, looking ahead, we're going to need circle P for problems 3 and 4. So, here's number 3, and this will be for number 4. So for number 3, we're supposed to draw a secant on the circle and label it line EF. So a secant is just going to be a line passing through the circle, something like this, okay, would be a secant. And so if I want to, there's more than one way to do this, but this could be E and this could be F, and that would make this line EF. And number 4, draw a chord on the circle and label it segment GH. So a chord is going to begin and end on the circle, okay, something like this. And if I call these endpoints GH, then I will have segment GH. Okay, so there's 2, 3, and 4. Use the diagram to determine if the statement is true or false. The distance between the centers of the circles is equal to the length of the diameter of each circle. Well, the distance from between the centers of the circles is 4. Yeah, I'm just counting squares. 1, 2, 3, 4. Okay, so that's 4. Now, the diameters of these circles, look at circle A, for example. Here's the diameter of A, and you can see that's 4. And here's the diameter of B, and you can see that's 4. So the distance between the centers and the diameters are the same, so that's true. Okay, look at number 6. The line y equals 0 and the line y equals 4. Please remember that the line y equals a number is a horizontal line. Okay, so if I talk about the line y equals 0, I'm talking about a horizontal line at 0. And if I talk about the line y equals 4, that's a horizontal line at 4. So the line y equals 0 is this line right here. This is the line y equals 0. And the line y equals 4 is going to be up here. That's 2, 3, 4. So this is the line y equals 4. So those are the two lines we're talking about. So these two lines represent all the common tangents of the two circles. Is that true or false? Well, that is false because there is another common tangent that goes straight down the middle, something like this. What would be the name of this line, by the way? What's the little equation for it? This would be the line x equals 5. Did I count that right? 1, 2, 3, 4, 5. Yeah, remember, if horizontal lines will be y equals a number, a vertical line will be x equals a number, so x equals 5. So that one was false, excuse me, because we were leaving out x equals 5. Let's see. Number 7, the circles intersect at the point 6, 3. True or false? That is false. The circles intersect at this point right here. Okay, that is where they intersect, but that is the point 5, 2, not 6, 3. So that is false. Number 8, suppose the two circles shown are inscribed in a rectangle. Okay, the two circles shown are inscribed in a rectangle. Having shapes that are inscribed inside of other shapes, that means that they are touching the sides of the shape in which they are inscribed. So Okay, so if I'm supposed to imagine that these two circles are inscribed in a rectangle, the idea is you're supposed to picture a rectangle like this. That's just touching the sides. I'm going to make that so you can see it in a second. Let me stick with red. Okay, so this red would be the rectangle in which these two circles were inscribed. See how they're barely just touching the edges. So, the perimeter of the rectangle is 36, true or false? Well, let's see. This side is, well, it's 4 and 4, so that's 8. Okay, so this side is 8. And this side is 4. So that's 8 and 8 and 4 and 4. Okay, so that is 24. So that is false because the perimeter is 24. Okay, so that is, how you could do that. So that was page 186 in somebody's textbook somewhere in the United States. Now, page 188, some additional problems that we need to do. Okay, state the best term for these things. See, do we have a word bank for this? I guess not. So, but point F, which is right here, it's a single point, so they just put F. That is the point of tangency, is one of our vocabulary words. So point of tangency is the best word for that. Line FE. Well, line FE is this line that goes like this. It is a tangent line, but more specifically, it is a common internal tangent. So we'll write all that down. Common internal tangent. Okay, because it goes between the two circles. Segment HG. Segment HG is a radius. Segment DB. Segment DB is a chord. Okay, now notice because of the symbol over the top of the DB, that's what tells me that this is a chord. This little symbol over the top of the DB is a segment. If this had been, well, look at the difference between number 4 and number 7. They both have DB, but this has a segment symbol over it. This one has a line symbol over it. All right, so number 4 means from D to B and you stop. So that's a chord. Number 7 means the whole line that keeps going forever, and that would be called a secant. Okay, so you have to pay attention to the symbol over the top. Number 5, C. Point C is just the center of the circle. Okay, segment BE is a chord, but more specifically, it is the diameter of the circle. It goes right through the center all the way across. That is the diameter. And let's see, line AG. Line AG is a common external tangent. Okay, so there we go for that set. Let's take a look at 9 through 12. Find the diameter and radius of circles A, B, and C. Well, guess what? All three of these circles have the same diameter and the same radius. Sorry, late night last night for the yawning. That is a radius, and all these radii will be the same. So the radius is 2. And of course the diameter is always going to be double that, which is going to be 4. Okay, for all of these circles, that's the same. Describe the point of intersection of all three circles. Can your eyeballs see the point where all three of these circles meet? Can you see it? What is it? I don't know if you really see it. It's right here. Kabam! All three circles meet at that point. And now, if we want to describe it, we're not just going to call it a pretty red dot. We are talking about what are the coordinates of this point. And that is 2, 3, 4, 1, 2, 3, 4. So it's not a very elegant description, but it is perfect nonetheless. 4, 4. That is our description. Describe all the common tangents of circle A and circle B. Well, let's start by drawing them. And remember from the other page that if we get a horizontal line, horizontal lines are always going to be like y equals something. Okay, let me just write this down. Horizontal lines. Whoa, that looks like limes. Horizontal lines are always like y equals something. Vertical lines, goodness, having problems today. Vertical lines. Okay, now it's just getting ridiculous. Vertical lines are always x equals something. So, the common tangents, and we're just looking at A and B, so ignore C for a minute. And I think I'm just going to cheat a little bit and use my tools. One common tangent would be like this vertical line right here. That's one common tangent. Another common tangent, similarly, would be this line right here. Okay, so just looking at A and B, those are two common tangents. Can you see another common tangent? Yeah, another common tangent is going to go right here through the middle. Okay, so there are 3 common tangents, and we can name them. The 2 vertical ones are going to be x equals something. So for example, this one will be x equals 2. This one's going to be x equals 6. And this is going to be y equals something because it's horizontal. So that'll be y equals 4. So when they just say describe all the common tangents, we really just need to list these things out. Okay, so we're just going to say x equals 2, x equals 6, and y equals 4. Those are all the common tangents. Now, describe the common secant of A and C that passes through both intersections of these 2 circles. Okay, so we're looking at circle A and circle C now. So sort of ignore circle B. Can you see a point where circle A and circle C intersect? Where do they meet? Well, I'm hoping you can see that circle A and circle C touch right here, but they also touch right here. So, it mentions both intersections of the 2 circles. So here are the 2 intersections of the 2 circles. This common secant, remember secant is a line that passes through the interior of the circle, passes through both of those intersections. So there's only one line that passes through both of these points. And so that must be what they're talking about. Okay, so that line would basically be like this. Okay, so that is the common secant that they're talking about. And so when they say describe it, just like for number 11, we gave these little equations of those lines. Let's give a little equation of this line right here. Remember, y equals mx plus b is the slope-intercept form that we use very often to describe lines. Y equals mx plus b. In this case, the y-intercept is 0. You can see that the y-intercept here, it's going to eventually hit 0, 0. So, so this b value is going to be 0. So I got y equals something x. So I need to know the m. Of course, the m is the slope, rise over run. So if I look at this line and try to see what it's doing, it seems to be going up 1 over 1, up 1 over 1. So that's, a rise over run of 1. So really, we're just going to have the line y equals 1x, because we don't have to put the 0, but we don't need the 1 either. So that's just going to be y equals x. So that would be the best description for this diagonal line that they wanted. So y equals x. Okay, and that is it for this assignment. Yeah, by the way, if you have found this video helpful at all, please do me a favor and hit like. Hit that like button, give me a quick thumbs up. It helps my channel grow, and I will be eternally grateful. Thank you very much.